Now we'll transition from 3D layer properties that apply to individual layers to 3D scene properties that apply to all the layers in a scene. And we'll start with the ground. Every scene has a default elevation surface that defines the height values for a scene. And the ground is from which all other layers measure their base height, for example. Now, the ground typically includes just one elevation surface, for example, a digital terrain model, but it can include multiple elevation sources. If, for example, you want to have a general terrain model when you're zoomed out, and then when you zoom into a specific site, you want to have a highly detailed terrain model. And you can combine those both in the ground. You can also add additional elevation surfaces for non-ground or custom surfaces. In the image below, we have a ground layer, which is the very top layer there, that represents elevation or topography. And then below that, we have custom non-ground surfaces that represent the tops of the stacked aquifers within that extent. And in this particular example, we've combined ground elevation surfaces, custom elevation surfaces, and extruded features to create a scene that simulates wells whose base height is set to ground, which is the very top layer, the ground layer, and extruded down to the top of the aquifer for which they're tapping. Another 3D scene property is background, where you can select a single color for your local or global scene. And we use background to highlight a scene or simulate sky, especially at the horizon line. Now, if you look in the images below, you can see on the left, I have a LiDAR scene of Barton Springs Pool, in which I've set the background in the scene properties in the general group to a dark gray, and that really highlights the LiDAR data. In the scene on the right, I've set the background to a light blue to simulate the sky and highlight that line between where my models are and the sky above it. Now, the background setting does an okay job of simulating the sky, but there's another setting we'll talk about in just a minute called atmospheric lighting that does a much better job of recreating the sky, but that's only available for global scenes. And when you set that, it overrides the background setting that you might have set in the general settings for your scene. Another 3D scene property that you set for all the layers that are participating in that scene is the coordinate system. And in a 3D scene, we should set the horizontal and vertical coordinate system. It's not required. Just like in a 2D map view, you can choose none for the horizontal coordinate system. But for a scene, you really should set the horizontal and vertical coordinate systems. And you should match the horizontal and vertical linear units. And this seems pretty obvious, but I can't tell you how much data and how many scenes I've seen feet used for the horizontal coordinate system and meters used for the vertical coordinate system. And it looks good, but it can create real problems when you're trying to analyze and measure data. If you look at the images at the bottom of your screen, you can see the one on the left, I've set the horizontal and the vertical coordinate system. The horizontal coordinate system is set to NAD 1983 State Plane, Texas Central Zone, and the vertical coordinate system is set to NAVD 88 height, but they both are set to the same linear units, which in this case is feet. Now, local scenes can use spherical and planar coordinate systems, but global scenes must use spherical coordinate systems. And that's pretty obvious because you're looking at the curved sphere on the horizon. And in the example on the right, I've selected the generic WGS 1984 for both the horizontal and the vertical coordinate system for the scene. When discussing 3D layer properties, we talked about lighting, which is a property that we can set within a layer to light or shade individual surfaces, features, or objects within a layer. But those layers have to be illuminated, and we do that in the 3D scene properties to provide a three-dimensional scene with depth. Illumination settings include position, shadow, and atmospheric lighting, and you can access all of those in the scene properties under the illumination group. Now, the position is the position of the illuminating source. In almost all cases, we're talking about the sun, and the default position is at 315 degrees and an altitude of 90 degrees. So in the northwest sky at noon with the sun directly overhead. Now, the problem with that is the illumination is pretty harsh and it doesn't really cast shadows. So I often change that to 45 degrees, or you can set the position by the time of day, and I'll set it for later in the day. Now, with the position of the illuminating source set lower in the sky, you can enable shadows for depth and realism. And for those 3D faces without textures, you can also enable ambient occlusion, which shows variation lighting on your faces. Last, for point clouds, you can enable eye-dome illumination so that you can illuminate the individual points in a point cloud and cast shadows, especially that emphasize depth in the point cloud. Last, you can set atmospheric lighting. This is for global scenes only, where you can enable things like atmospheric effects to simulate filtered light, stars and halo to replicate the horizon, and even, although it's not part of ArcGIS Pro now, I think it will be in the future, a sky dome for clouds, in which you have a sky dome mesh that you add, and it really, really adds a lot of realism to your scene. So if you look in the upper right-hand corner of this slide, you can see the map properties in the illumination group, all of those properties that you can enable and set, including position, shadow, and atmospheric lighting for global scenes only. And you can see the dramatic impact illumination can play in a scene. In the top scene, I'm only positioning the sun at an azimuth of 315 degrees and an altitude of 90 degrees. And there's not a lot of depth to that scene. But if you see, if I enable a lot of the illumination properties for the scene, including position, shadows, atmospheric effects, ambient occlusion, and stars and halo, it really has a dramatic impact on my scene. Now shadows are casting on my ball field. The light is being filtered through the atmosphere. It creates a little bit more of a golden light. And ambient occlusion is showing slight variations in how my faces are lit on an untextured surface. Last, if you look to the horizon, I don't have just one single color representing the horizon. I can introduce an atmospheric halo like I have here, or even stars if it was twilight or night. The last 3D scene property I want to discuss is drawing properties, which allow us to render layers in order and scenes in perspective or parallel. In the lecture demonstration, we saw where you can have Z-fighting when features or surfaces occupy the same X, Y, and Z location. And so we use depth priority to resolve these visual conflicts. And you can see in the upper right-hand corner, I've set the depth priority for trees, contours, and building models, with trees being the highest priority, building models being second, and contours being third. And so this will resolve any Z-fighting or the flickering that occurs in your scene when these features occupy the same location. We can also set the drawing mode as perspective or parallel. Perspective, which is the most common drawing mode, and we almost always use it in GIS, the features in the foreground are larger than those in the background. Now, parallel, which we use for architectural and sometimes stylized statistical scenes, the features in the foreground and background are the same size. And you can see the difference between perspective and parallel and how you set that on the view ribbon in the image in the middle of your screen and the image at the bottom of your screen. In the middle, we have perspective set, which is the mode we most often use in GIS. And at the bottom, we have parallel set, which you can use again for architectural and statistical scenes. In closing, when you put all of these 3D layer and scene properties together and you configure them correctly, you can create some truly amazing and beautiful scenes. This image right here, which looks like a real photograph, was created in ArcGIS Pro. And we utilized all of those settings we discussed: lighting, shadows, shading, atmospheric effects, even a sky dome, to create this really magnificent 3D photorealistic scene.